Steve Colbert.
We are faculty here at Hilo in the Marine Science Department, and we're here tonight to tell you the scoop on the poop. Sewage pollution in Hawaii's drinking and coastal waters. So just a brief outline for our talk. We're going to start off talking about the importance of coastal waters here in Hawaii. We'll also be discussing sewage treatment options, focusing on the fate of sewage, where it goes. We'll then talk about the impacts of sewage to the coastal waters, how we detect the sewage if it's there, and what do we know about sewage pollution in our coastal waters and drinking waters here on our island. And then we're going to be wrapping up talking about considerations for communities who are facing this type of pollution problem. So coastal waters are some of the most biologically and economically diverse ecosystems, providing hundreds of billions of dollars in food, jobs, recreational opportunities, coastal protection, and other valuable services. In Hawaii alone, they account for over $800 million annually to the state economy. And coastal waters, in particular the coral reefs here, are culturally important. For example, in the Kumulipu, the Hawaiian creation story, it starts off with the creation of a coral polyp. And in Hawaii, there's a tremendous economic and cultural reliance on both the quality and health of the coastal waters. Approximately 17% of the state economy is based on tourism, and tropical beaches in the U.S. receive more visitors than all the temperate beaches combined. However, Hawaii has a chronic sewage problem, ranging from direct disposal into estuaries, sewage spills that happen frequently and have been happening more often recently with our heavy rains, sewage injection wells like the ones in Maui, and then most commonly cesspool leakage, and this also occurs for septic tanks as well. And we hear about these sewage problems actually pretty frequently here in the state. There are numerous headlines in newspapers and on the television. Here's just a sampling of them spanning from 2005, where they talked about efforts to clean up Hilo Bay, to headlines in Maui, Kaneohe Bay, as well as on Kauai, and then even recently where the EPA has asked the county to fix our sewage outfall. So this problem isn't particular to our island, it is a statewide issue. And one of the earliest examples of sewage pollution effects on coral reefs comes from Hawaii State, from Kaneohe Bay on Oahu. And here, back in the early 70s, they were discharging effluent from the sewage treatment plant into a stagnant portion of the bay that didn't flush out very well. And as a result, what happened was they saw up to a 99% reduction in the coral cover as the algae shown up here, the bubble algae, overtook the reefs. Now, this is actually considered a textbook example of how sewage pollution impacts coastal waters and coral reefs in particular, but it is also an example of when the appropriate actions are taken, how a coral reef system can recover. And I'll return to, Steve will return to that at the end of the talk, talking about the potentials when actions are taken for the system to come back.
So after you flush the toilet, you hear the gurgling sound, and what happens? Where does it go? Well, for a large part of our water, it ends up eventually at the shoreline. There's a few steps in between there, though. First of all, most of Hawaii Island, we have 60,000 on-site sewage disposal systems. Most of those are cesspools. And I have a picture of a cesspool here at the bottom for those of you that aren't sure what that is. Most homes around the island are connected to a cesspool. It's nothing more than a bit of cement with holes in it where solids can settle out in the middle and liquids can just flow right out and into the surrounding groundwater. So basically, for Hawaii Island, that's releasing about 35 million gallons of raw sewage a day into our groundwater. For those of you on the map up here, the colors, the warm colors are showing us where we have high concentrations of cesspools. Red is where there are the most cesspools, and green where there are the fewest. So you can see where these population centers are around the island with these high densities of cesspools and on-site sewage disposal systems. In Hilo, you can see right about there, there's a little bit of turquoise blue. Those are public wastewater treatment systems. Sewer systems where the wastewater goes to a sewage treatment plant, it gets processed, and then discharged. In Hilo, we discharge that water out at a sewage outfall outside Kui Bay and Keaukaha. There's a few other of these plants up the Hamakua coast where we have discharges at the shoreline. And over in Kona, I'll come back to how they do their discharge a little bit later on. Some places use injection wells, like the Lahaina treatment plant on Maui. And then for the third option is private treatment facilities. And these are run by most of the resorts along the Kona coast. Each resort has its own sewage treatment facility, and then they either use that water for irrigation purposes, or they inject it back down into the groundwater. The water that reaches our groundwater, about 50% of all sewage in the state goes into the groundwater. And that percentage is even higher for Hawaii Island because of how little that we have that's in sewers. So, of that water reaching into our groundwater, all of that sewage eventually finds its way back to the shoreline. Our groundwater flows downhill, out, and discharges at the shoreline. You felt that groundwater. You've been there, you've been to the beach, and at the groundwater it's colder. We have that cold water coming out. That's what this picture on the left is showing in the top here. This is an infrared camera image of the Puako coastline. And what you see is in blue, these regions where cold groundwater is coming out and then mixing with warm seawater farther offshore. I did a study at Puako where we put dye in people's cesspools on their property to measure how long it would take for that sewage to reach the shoreline. That's what's being shown in this figure here. We injected the dye. After about 3 days, we begin to see the dye at the shoreline. After 5 days, we have really clear evidence of that dye at the shoreline. That sewage is coming out in 3 to 5 days from those oceanfront homes to the shoreline. At the Lahaina, on Lahaina on Maui, they injected dye into their system and measured how long it would take to get to the shoreline. It was traveling about 0.6 miles, and it took 5 months before they saw the first signature, and then the largest peak at about 10 months afterwards. And that's where all the sewage from a sewage injection well is then finding its way to the shoreline. And the result of those inputs are these blooms of algae along the Maui coast, so having a definite impact on the coastal water quality.
So sewage can have lots of different impacts. One of the first is that it can affect the health of recreational water users. In 2009, there were over 18,000 beach closings within the United States. 74% were due to high levels of fecal indicator bacteria. These levels were exceeding the state standards. And about 21% of these closings were precautionary due to rain events. So we have these often in Hawaii where we have heavy rainfall and the rivers are bringing a lot of groundwater into the estuaries. And just as a precaution, we recommend that recreational water users don't go in during those times. We have also seen that there's been a significant increase in the number of waterborne diseases and gastroenteritis. They've been reported since the 1970s. This is the time when the Center for Disease Control started reporting these incidences. And when these outbreaks happen, it affects local economies, especially those that are dependent on tourist revenue, like here in Hawaii. In addition to Hawaii's sewage problem, there is also a high incidence of prevalence of infections that are associated with recreational water use. It includes things from skin to gastrointestinal infections. Many people may have heard people talking about staph infections that they get after they go swimming or surfing. And that's not just the only one. There's things from salmonella to campylobacter, Vibrio. And these type of pathogens, here is a map from Oahu. What they saw is that these type of pathogens are found both in the coastal streams and waters in those islands. They are associated with different types of land use, and things like staph, where we're concerned a lot of people are getting staph infections, and they're thought to be associated with their recreational water use, might be coming from sewage, because this type of bacterium has been found in sewage. We also know that staph has developed a strain that is saltwater resistant. It is also resistant to some types of antibiotics, and the one that we're most concerned about is MRSA. And I've heard anecdotal evidence that somewhere about 90% of the staph infections that the physicians see here in town are MRSA. And these type of things make headlines. Hawaii leads the nation in deadly staph infection, and in fact, it's 2 times the national average. We also have other types of waterborne infections like leptospirosis, which is also associated with groundwater events. So in addition to the human health risks of swimming in coastal waters that are polluted with sewage, there are ecological effects as well. And as the sewage is released into the coast, a cocktail of nastiness comes out with it. The pathogens that we just talked about, nutrients, all sorts of household chemicals, hydrocarbons, anything that goes down your sink or down your toilet eventually makes it into the coastal waters. And these different chemicals have ecological effects. They can cause coral reefs to go from a system where it's coral dominated to one that is dominated by different seaweeds, like this picture here shown in Maui. In these areas, we see declines in coral and reef fish abundances. We also see increased prevalence and severity of coral and reef biota diseases and infections. And here are just some of the pictures of the types of coral infections we see in these types of areas. So how do we actually detect sewage pollution in these coastal waters? And the most common way that we do this is a single sample measurement looking for fecal indicator bacteria. These bacteria themselves aren't necessarily pathogenic, but they're indicative of other pathogens that could be coming in with the sewage that could be harmful to humans. The one that we use for marine recreational waters is Enterococcus, and its presence is supposed to be indicative of sewage pollution in coastal waters. However, researchers from Manoa have documented that Enterococcus is naturally found in tropical soils, and therefore when you find a high abundance of it, it might not necessarily be indicative of sewage pollution. Enterococcus can also multiply in the environment, so the levels might not necessarily be indicative of the pollution levels in the waters. And because of these 2 factors, Hawaii State has adopted an additional fecal indicator bacteria, Clostridium perfringens. This is an anaerobic spore-forming bacterium, so once it's in the environment, it doesn't multiply. It's found in the human intestinal tract and other also warm-blooded animals. And unlike Enterococcus, it doesn't multiply in the environment. So this is thought to be a better indicator of sewage pollution, because once it enters into the water, it's not necessarily multiplying, and it doesn't have as many different sources as Enterococcus. But these types of methods have limitations, because you have to go out, You have to collect a water sample, bring it back to the lab, and then you have to process it. And this takes over 24 hours to get an answer. So by that time, it takes 24 hours to do a posting. And during that lag time, people might be actually going out into the water and being exposed to the pollution. In addition, this method is also very costly and labor intensive, and often limits how many samples we can go out and collect. So for example, here on Hawaii Island, there's only one guy that works for the Department of Health, and he's responsible for collecting all samples on the island. So you can imagine he can't go to every site all the time, and he's limited by when he can actually go. The other complication with this is that researchers have shown that the levels of these bacteria can fluctuate on very short time scales, from the order of minutes to hours. And so to really get a good handle on this type of pollution, you need to be out there sampling all the time. And we know that this is just not feasible for a lot of departments of health to do. Because of this, there's often a high error in beach postings. We can't sample enough. We don't get the answer quick enough. And so sometimes people are accidentally swimming in polluted waters before we actually know there's a pollution problem. And also sometimes we aren't opening the beaches soon enough. And so these states like Hawaii are losing tourist revenue when the beaches might be safe to swim in. And so we need better methods to be able to detect the pollution and to do it quickly in real time. Another method that scientists are using now to more accurately measure if human waste is in the waters is by looking at a bacteria known as Bacteroides. This is the most abundant bacteria in the human gut. It's also found in other warm-blooded animals. And it doesn't multiply in the environment like Enterococcus does. And we actually have molecular tags that we can use to identify whether the Bacteroides in our water sample is from human or for other types of animals. So we have molecular primers for humans, dogs, cows, horses, pigs, deer. So we can actually see where the bacteria is coming from. And this technique is known as molecular source tracking. And this can be very useful for identifying the pollution source and then taking appropriate actions to mitigate it and maybe reduce the amount of pollution coming from that particular area. Another tool that's being developed as well is a real-time decision or swimming advisory of beach closings. So what they do here, remember I said there's that 24-hour lag between collecting your water sample and knowing whether you should close the beach or open it because it's safe. Well, if we can make real-time predictions using sensors that are already out of the environment, we can make real-time closings about when it's safe or unsafe to swim in the waters. And we can do this with sensors that are already out in the environment, like wave buoys, gauges at the river measuring discharge, rainfall at the airport, water quality buoys like we have in Hilo Bay that are measuring turbidity. And using all that information, bringing it into a computer model, we can make real-time predictions and tell people when it's safe to go swimming. And this type of tool has been used widely in the Great Lakes. This is where they've really developed it. They call it a nowcast. So it's like a forecast, like a weather forecast, where you're trying to predict what the weather will be like in the future. But here we're predicting what are the conditions now. So can you swim or can you not go swimming? And these models have primarily been made for the Great Lakes, focusing on another fecal indicator, which is E. coli, and that's the one that's used in freshwater systems. This type of model hasn't yet been developed for Hawaii, but we are actively seeking funds to try to develop this tool because we already have these sensors out in the environment. We just need to develop the model so we can make real-time calls about when it is safe. And then the last tool I want to talk about how we detect sewage in the environment is using stable isotopes in nitrate. Nitrate shown up here is a nutrient. It is found in sewage, but it's also found in other pollution sources like fertilizers. And when we look at the elemental composition of the nitrate, we can tell what source it actually came from. Sewage has a very distinct signature from that of fertilizers, from groundwaters, from leaf decomposition in forests. And so we can tell whether that nitrate in the water is from sewage, and we can also see by sampling the seaweeds that are growing along the shoreline whether they are taking up nitrate from sewage as well by analyzing the nitrogen in their tissues. So what I'd like to do now is to talk about what we know about our coastal and drinking waters here in Hawaii. And I want to focus on 3 locations where we've been working over the last 10 years. And I want to start off closest to home in our backyard in Hilo Bay. We've been studying sewage pollution here since 2006, primarily focusing on inside the breakwater, but we have just recently started to be collecting data in Keaukaha. I won't be presenting those results today, but just focusing on what we do know inside of the harbor. And I'm going to be presenting data looking at those different types of indicators that I just discussed, because we've been using those tools to see if we can detect sewage pollution in our coastal waters here on the island. Here we have a graph looking at Enterococcus for various stations in Hilo Bay. We sampled during both high flow conditions shown here in black and low flow conditions shown here in gray. And what we see is that oftentimes the Enterococcus levels we're measuring in Hilo Bay, they actually exceed the Hawaii Department of Health single sample maximum standard. So this is the standard that no single sample should exceed. And you can see in some cases that it exceeds it almost tenfold. And we primarily see the highest concentrations of Enterococcus following storm events. We've also made measurements for Clostridium perfringens. Remember I said this is the secondary fecal indicator bacteria the state uses. It also, like Enterococcus, often exceeds the state standards, but not quite as often. And we typically see the highest levels for Clostridium during high rainfall events. We also see the highest levels at the river. So here we have Wailuku River, and over here we have the Wailoa River. We've actually seen a significant relationship between Clostridium levels and the discharge of the Wailuku River. And this tells us that Clostridium is coming out of the watershed. It's not telling us exactly where it's coming, but it's coming down the rivers, and the concentrations are increasing following large rain events. Now, while it's important to measure these fecal indicator bacteria, because that's what the Hawaii Department of Health uses to determine whether water bodies are in compliance with state standards, it's also important to try to figure out where the heck are these bacteria coming? Are they from sewage? So to do this, we made measurements of Bacteroides, and we looked for the human molecular marker. We wanted to know if those Bacteroides in the water are from human waste. We collected over 200 samples, and what we found is that somewhere between 40 to over 50% of the samples tested positive for the human molecular marker for Bacteroides. And what this is telling us is that human waste is present in Hilo Bay. The stations that had the most positive hits for this were at the river mouths, and we tended to find the most positive hits following rain events, although that wasn't statistically significant. Another area where there's been concern about sewage pollution is down in Kapoho. And there's been a long time concern going all the way back to the 1960s about sewage pollution here. And in the 1980s, the Hawaii Department of Health came out and did a dye tracer study like Steve described that he did at Puko, where they put a fluorescent dye down one of the toilets on the oceanfront homes. And here, they found it, they detected it in 20 minutes in the tide pool in front of the home. Since then, there's been lots of efforts to try to do something about the sewage pollution down in Kapoho. There's been concerns about human health threats as well as concerns about coral diseases in this area. And like I said before, there's been many efforts to try to do something to improve the conditions. They haven't really, and in particular, tended to be highest at the Department of Health sampling station. And these values were in line for what we see for Hilo Bay typically during low flow conditions. But like I said before, Enterococcus can be a little tricky to interpret because it can have other watershed sources. So we also made measurements for Clostridium perfringens too. And what we found here is that the levels were higher than the recommended standard to the Department of Health, which was about 5. But the levels weren't as high as the ones as we detected in Hilo Bay. And it was only under certain dates, so this is looking at C. perfringens, only certain dates where we saw the levels exceeding the state standard. So it was only intermittently where they're crossing over that 5 marker and going into the range of non-point source sewage pollution contamination. What that is suggesting is that when we hit those higher levels, it's indicative of possible cesspool leakage into the coastal waters. But this is not the consistent condition. It was only sporadically that we would have these hits. And more recently, the Pu'uko Community Association approached us. This was about 2 years ago. And they were concerned that sewage pollution was coming into their nearshore waters and impacting their reefs. And they really were motivated to do something. But they can't do anything unless they can first demonstrate that sewage pollution is present in their coastal waters. And so we took out our toolbox and went here to make measurements. And the first thing we sampled was the seaweed. We wanted to see if the seaweed had values indicative of sewage pollution. And we sampled 16 stations along the Pu'uko coastline. And we found that in some locations in particular, the seaweed had values that were indicative of sewage pollution. And these arrows over here are showing those locations. And the 2 down here towards the south of the shoreline is where Steve did his dye tracer studies. So these 2 pieces of evidence, nitrogen-15 values in the seaweed as well as the dye tracer test, are indicative of sewage pollution coming into the shoreline at those particular locations. We also measured Enterococcus and found that it had high levels as well, oftentimes exceeding state standards again. But like I said before, Enterococcus can be tricky to interpret, so we also made measurements of Clostridium perfringens. Here again, we did have high levels of Clostridium. These values are similar to the ones we've detected in Hilo Bay, and these are also higher than the ones that we see in Kapoho. They're within the range, are within the range of what we see for non-point sewage pollution. And this confirms already the other measurements that we're seeing. So the cesspools in Pu'uko, a few of them are leaking sewage into the nearshore waters. Steve's now going to talk about sewage pollution impacting drinking waters.
All right, we're in the home stretch here. We promised to talk a little bit about drinking water and how our drinking water quality may or may not be impacted by sewage. For the most part, if you're drinking county water, you have pretty good quality water there. There are a lot of regulations that go into public drinking water systems through the Clean Water Act, the Clean Drinking Water Act, that allows us to have good water quality. This is a map of Hilo showing you, in case you didn't know where our water was coming from. There are, here we are on campus. As you go up Saddle Road, there's 3 main wells there. There's also an additional well over in Panaeva that's used occasionally depending on the quality of water. And what they're doing, they've chosen those locations for a couple of reasons. You can't go too high because then it's very expensive to pump the groundwater up from deep down. So you can't get to too high an elevation. They're picking a location that's right below areas that are covered in conservation ground, so that there's no houses, no injections, nothing going on Mauka of those points. And therefore, they're able to maintain the finest water quality that they can. They have these wells for the Hilo area, but there's also all around the county wells that have been defined for drinking water, giving us relatively good sources of water. Now, in some communities, they aren't on county water. County water doesn't reach every place, and so a lot of people are on catchment systems. And if you're in a low-lying area, there is the attraction of putting in your own personal groundwater well. County uses groundwater, why shouldn't I use groundwater at my house? And the reason why you shouldn't is because of this situation coming up, where you have your cesspool upstream from your drinking water well. So you just do it the opposite, right? You put your well on the other side of your drinking water well. It's not that simple. And I'm going to present here a study that's been done by the Department of Health, looking at the impact of cesspools on drinking water in Hawaii Paradise Park. Here we have the distribution of cesspools. Each purple dot is a cesspool, and the colors, the reds, are the density, how many cesspools that we have in an area. And what you can see from that is we have this very high density of cesspools here. It's the highest in the entire state, and even by EPA standards, this blows it out of the water for high density cesspools. Zooming in on HPP, the purple dots, the blue dots on here are wells, where people have put private wells on their property. Maybe they're using these for irrigation, they're using it for drinking water. There's about 250 wells that have been put in HPP. And you can see they're very close to where the cesspools are. So the Department of Health went out and they tested 32 of these wells and measuring them for the fecal indicator bacteria, whether they were present or not. Of the wells they tested, 50% of the wells tested positive for total coliform. Total coliform being one of the freshwater indicators of sewage pollution. Of those wells, 8 of them tested positive for E. coli, 25% overall. And that's what's being shown in the figure here. The shading is showing where they were more likely to have hits of total coliform. The point being here is that in these wells, they are finding sewage in them. And as you move closer to the shoreline, they're finding more evidence of sewage, which makes sense because that's the direction that the groundwater is flowing. And as the groundwater flows towards the shoreline, it's getting this continuous input of sewage from everyone's cesspool. And as a result, the water quality is deteriorating. And that's just for the indicator bacteria. Like we mentioned earlier, sewage is a cocktail of nasty stuff. There's other stuff in there that can harm you that may be lasting longer in the water than the indicator bacteria do. All right, now on to the driest part of this talk. Some questions about, well, who's in charge of this? And what are the regulations controlling our standards for drinking water? And this was something that it really got to me because I wanted to know who are we supposed to look to? If we want to do something about this, whose door should we be knocking on? And it came down to, well, the people who are in charge is primarily the Department of Health. And the Department of Health, they have lots of different branches, and 2 of them that deal with water quality are the Clean Water Branch, and what they do is regulated primarily by the EPA, the Environmental Protection Agency. The federal EPA is tasked with the Clean Water Act. Okay, so we have this federal Clean Water Act. The EPA has set water quality standards that every state must meet, and it's the Department of Health's Clean Water Branch's job to make sure we're in compliance with those EPA standards. And what they do, what the Department of Health does, is they set water quality standards, they go out and they measure the water quality, and they're also interested in outfalls. So if you have a sewage outfall going into surface water or into an estuary, that they're monitoring those conditions as well. That's all being done by the Clean Water Branch. On the other hand, we have the Safe Drinking Water Act, and it's the Department of Health's Safe Drinking Water Branch that takes care of that drinking water. They make sure that your drinking water is of the highest quality, and they let people know if they need to boil their water or something because there's been some contamination of it. It's that branch that goes through and doing that. Now, what they're looking at, now, like I said earlier, most of our drinking water comes from groundwater. And so they're concerned with what the quality of the groundwater is, particularly Mauka of the well, because our groundwater is going to be flowing downhill. What happens below our drinking water wells isn't very well regulated. Let me say that again. There's no EPA or state water quality standards for groundwater Mackay of our drinking water wells. So in these areas where we have the highest densities of people, where we have the highest densities of industry, these are places where you can put in an injection well, you can put in cesspools, and you have to file paperwork saying what you're putting down there, but whether there are no standards for what that water quality has to be. So the regulations on it are very weak. I'll show you an example here. This picture on here is the Kealakehe wastewater treatment plant, just outside of Honokahau Harbor. This is their sewage outfall. Do you see the pipe here? And the water splashing out onto the ground? They don't have to worry about any regulations on it because they're not injecting it into surface water like a river. They're not even using an injection well. They're just getting rid of it. I'll come back to your question at the end. But the issue here is, in terms of this, we're losing out this water. It's impacting our coastal water. The other part is that individual homes, individual septic systems are also not impacted and required to have this type of permitting that's required of other systems. As we go forward, we have change for the better that's happening. And there are things happening that are going to affect change in how our wastewater is disposed of. Most recently, there's been this court case on Maui where they've been looking at the Lahaina wastewater treatment facility. Here it is, a little over a half a mile from the shoreline. Some researchers from UH Manoa injected dye into their injection well, and about 5 to 10 months later, they observed it here at the shoreline. There was already these other indicators of nitrogen isotopes, suggesting that this was, and high nutrient concentrations, suggesting that the sewage was reaching here. But in reality, it wasn't until they did this dye tracer test that they could actually link it back to where it was coming from. The result of this is that now their injection well is going to be treated the same way that a sewage outfall would be treated. And they have to get permits that control how much and what's in the waste that's going into the receiving waters. This is going to be happening for the Lahaina treatment, but it'll probably be expanded across the state as this continues to move forward. The other big thing that's happening right now is there are proposed rules to ban all new cesspools in the state of Hawaii. There are 49 states in the United States that have already banned cesspools, and only one that still allows them, Hawaii. So we're behind the times on this, and thankfully it's finally going to get changed here, hopefully in the near term, to ban any new cesspools from going in. And if you follow this whole story from a little bit from last year when they began this, there's been some changes to it. The big thing is that they're only banning new cesspools, and they're providing money for people who live basically right at the shoreline. If you have an oceanfront home, they'll provide some support for replacing your cesspool. Challenges come up if an entire community wants to change and do something about this. Doing something about water quality and sewage pollution is a lot more than just about human health and ecosystem issues. It's about what an entire community wants to do about this, because we have different members who live in our community, we're geographically different, and then there's also political constraints on what we can actually accomplish. So we've been looking at this and working with some of these communities, and we've kind of seen how the process goes. The first step that needs to be done is that the community needs to define, is sewage pollution affecting the things that they care about? And then the second step is to decide, as a community, do they want to do so? If it is, if sewage pollution is causing an impact on what they care about, do they want to do something about it? And if they come to that decision that they want to make a change, the third thing to do is to find a person, a leader in their community that can push this forward and find the appropriate political and agency support in order to make the change happen. Because it takes resources. It can't be done easily. It can't be done simply. And the whole community needs to come up with that decision. It's a tall order for any community to do, and without complete support, it could suffer from falling apart. And I think we don't want to end on a down note, and so it's important to ask, well, is it worth it? Is it worth making the changes? And the answer is yes, absolutely. There have been many studies done on what happens if you stop polluting the waters, what impact it has on a coral reef. This is a study that was done off of South Florida, where they added nutrients to a coral reef, and they wanted to see what happened. What they were using as an indicator was coral health. So here, they had background levels of coral health, and then where they added nutrients, they had much higher levels of coral disease that we're looking at. Higher levels of coral disease when they added nutrients to this reef. They did this for a few months, and then they took away the nutrients. They stopped adding nutrients and let it go back to background values. After 6 months, the control site and the added nutrient sites were indistinguishable. After a year, still indistinguishable. By getting rid of the extra nutrients, the reef was able to, the coral disease ended up going down at this site, improving water quality. But we don't have to go to Florida to look for evidence of this. We've got our best case of this right here in Hawaii, over on Oahu, in Kaneohe Bay. In Kaneohe Bay, they used to dump sewage into the bay, treated sewage into the bay, and within 10 years of stopping that sewage input, coral cover had doubled, had returned to pre-sewage input levels, and algal cover had dropped because there weren't the nutrients there for the algae to take on. So by cleaning up these coastal systems, improving the water quality, it'll definitely have a benefit on human health, but also on our ecosystem health. So just quickly to wrap up, we're at the end here. Thank you all for coming out here tonight. Sewage, I think we've shown you that sewage in Hawaii's coastal waters has an impact both on human health as well as on ecosystem health. Communities that want to go out there and do something about this and change things have to deal with some regulatory issues that don't necessarily help them out. And it can be a bit challenging in order to get this improved. And then finally, by improving our water quality, you can affect positive change, but it'll take time for that to happen. So with that, we'll gladly field your questions. Thank you all for coming out. Yeah.
The example that you showed us looked like land-based discharge.
Yeah.
What level of treatment was being taken place there? Was it primary, secondary,
It's
tertiary?
because it's a public wastewater treatment facility, they have to treat to secondary unless they have other releases. But I'm pretty sure they're treating to secondary water quality, and they are probably also disinfecting it before releasing it. Yes.
What technologies are out there apart from the standard cesspools that can help people deal with pollution like this in a decentralized manner?
That's a great question. And I believe it's going to vary depending on, the best solution is going to vary depending on the community and how it's set up. And the best example of that is like the Keaukaha community here in Hilo. They're largely on cesspools still, but they're very close to a sewer line. And so for them to be able to plug into a sewer system may be relatively easy to do. Whereas someplace that's isolated, like the Kapoho community, they're going to need something that's a different type of treatment option for them.
Do you know much about the current status of composting toilets at the state level?
I don't know what the status of composting toilets are. I know that there are a few of them around at small facilities, but I don't know about them larger. But you're right, there are these different options of composting toilets, aerobic septic systems that may provide adequate water quality if they're maintained properly, packaged plants, these small systems they can accommodate entire communities. But no one can come in and tell you this is the right solution for that community, because it's going to depend on what resources are available, what's available in that community. Yeah?
You know, your image of HPP is a frightening one, particularly when you actually tilt it up and see how many lots there are miles of highway. But there's a new well being drilled daily, and there's a new cesspool being put in every day in that subdivision. And but there is no central control. This isn't a Clean Water Drinking Act, DOH managing a public water system. This is private guys putting a hole next to their own cesspool and expecting it to be okay. So, I mean, just trying to wrestle with what prompts change in that environment, aside from an outbreak of sickness. We tend to respond to the things we care about, and if we don't care, it don't matter.
And that's where I think education is important, and making sure that the people know that when they're tapping a well in those areas, that they need to understand that water quality may not be, it depends on what they want to use the water for. Maybe some of these people are just using it for irrigation, and that's fine. But if you're going to use it for drinking water, then they need to have a filtration system, something cleaning that water to make it appropriate for that. But I think in those cases, I think it's the education that's going to be important.
And most of those houses don't have access. They're down below the rain line, so catchment is not an option for them, so it's their method for getting rainwater. They're only really drilling in the lower 10 or so lots.
Well, and then the other option is getting the county to do something about it, and getting it at the IDAC.
If you can't do it in Puna, you can't do it at Kapoho, and you can't do it in Hilo, why would you do it at HPP?
Yeah. Well, at least Kapoho finally got the county drinking water.
Yeah, where were you saying those lots are located? Right on the ocean interface?
Well, in maybe the first 10 up to 10th or 15th coming up HPP.
Okay.
Because if you look at the map, you'll see them concentrated there. It's because it's dry and they can't catch enough water on their roof to supply their own water, which most people in HPP do.
Yeah,
I have an impression on the septic system would be much better than cesspool. But did I hear either you, Tracy, mention that some cesspools,
some septic systems are not, we are in a unique environment here, especially on the Hilo side, on Mauna Loa and Kilauea, because we don't have the soil development that's required for septic systems to work well. A key part, the most basic septic system is just a tank that holds the sewage for some amount of time, allowing for some breakdown of that material, and then it flows out into a drainage field. And in that drainage field, it percolates through some sand and gravel, and as it percolates through that, it continues to break down the organics, and it also helps to capture the parasites and other E. coli, and it gets removed as it's moving through that soil bed. And if you don't have soil, if you don't have enough soil, then you're not removing those components. There was a talk just given earlier today on Oahu where they were talking about this issue of how well septic tanks work. And in places without enough natural soil, they were finding that they were very poor at effectively removing the microbes in the sewage waste. So in those environments, in terms of removing those human pathogens, I think that it's not as effective. The other part of it, though, is the nutrients, and I think that ends up being a big issue that isn't as well noticed. The EPA doesn't care about our nutrient inputs because it's a local issue. It's not a federal issue. Not every state has coral reefs. We have coral reefs here that rely on low nutrient conditions. And so when we're adding sewage, or even treated sewage, a lot of times most of the nutrients are still in that water, creating high nutrient systems, which in a worst case scenario is what happened in Maui and Lahaina, where they've had this outbreak of these algae blooms and smothering the coral. So we need to have systems that are effective at removing the nutrients as well. There are aerobic septic systems that can do that, but they have issues too. They have to be maintained. They have high electricity costs with them. There's no silver bullet.
Oh, and the other thing I was going to mention too is in at least the 3 areas where we've been doing more work, like Keaukaha, Kapoho, and Puko, when they actually go to maybe replace their cesspool and put in a septic tank or even an aerobic treatment unit, they're drilling in water. They're putting their unit in water. So the leach field is in the aquifer. There's no soil there. So there is no difference between a hole, which is a cesspool, and a tank which drips out, which is a septic tank, because you don't have that soil processing. So in these low-lying areas where the water table is just below the surface of the ground, you got to have something more, because otherwise your raw sewage is going into the water.
is there a solution for that?
Well, at Puko, the community is very motivated, and they just recently had a feasibility study done where the Coral Reef Alliance hired an engineer to come in and look at some options. The option that the engineer and also an advisory board that both Steve and I serve on had recommended a package plant for that area. So the 2 ideas that we had, that one was to build a package plant, have all the houses connected in. The reason why that was suggested is because at the package plant they would reduce the nutrients down as well. The other option that they're considering is bringing in a sewer line that would connect them to the Maunalani Resort just down the street. The only downside with that is they don't do the biological nutrient removal. So, but either option would be great because then at least they're taking the sewage out of the water table and treating it to some degree before it's released back into the environment.
I was curious if you guys know how many wastewater treatment facilities we have on the island and how close those systems are.
There's 4 public wastewater treatment here in Hilo, that's on the east end of the airport, located on the east side of the airport. And then the sewage outfall is close to the breakwater, heading out from Hawai'i Bay.
Yeah, so if you're down by Pack Rack, there's a big concrete pipe. It goes out from there and it's what, like 4,000 feet offshore and about 50 feet of water. And so the pipe has these diffusers, and then the treated sewage just kind of, diffuses out and mixes in with the ocean water.
And then there's one in Papaico and two more going up the coast here. And then there's the one other public one, which is in Kailua Kona. But then there's several other privately owned sewage treatment plants, like at Waikoloa and at the Manalani, has investor companies that run sewage treatment plants. And then there's several at the resorts. I don't know how many they number.
But also, just to let you know, back, was it 70s or 80s, before I lived here, but they used to discharge the sewage inside the break wall. And luckily now the outfall's on the outside of the wall, so it mixes better with the ocean water. But it used to be directly in the bay, just like in Kanaoe, they put it into a section where it did mix very well, and there was lots of repercussions as well.
Question for Professor White here. Would harvest of old rules of seeds after or before a rainstorm be safe for consumption?
I guess the concern is you want to make sure you wash it really well.
True.
It's just like if you were to go into the water and swim during a rain event, which I wouldn't necessarily recommend doing, even though the surface could. You want to make sure you wash well afterwards so that you don't get any bacterial infections on any open cuts. So same thing, if you were consuming seafood, you want to make sure that you really got the film off the surface, because it's not necessarily the nitrogen that's going into the tissue that would make you sick, but if there were any bacteria or those pathogens from the sewage on the surface of the seaweed, if you ate that, that could make you sick.
Thank you.
Is there any type of organism or fungus or something that could be released into the injection wells to break down this bacteria?
I think that has to be done ahead of time, and that it ends up being, there's a whole, there's a lot of engineering that's gone into developing sewage treatment plants and cleaning up water all the way to the point where you could drink the water, that they've removed everything and purified it to such a high level. So there are sewage treatment options that can make the water of a higher quality. I'm not saying that we need to treat it all the way to the point of drinking water, but it needs to be better treated.
And in Orange County, California, that's what they do, because they had too many people. They didn't want to build more infrastructure because they didn't have the money. And then they were also concerned with the salt water pushing into the aquifer. So what they do is they treat the sewage to the umpteenth degree. Then they ship it back up Mauka and they re-inject it in. So if you're in that area, you probably don't want to think about this, but if you're drinking water in Orange County, you are drinking treated sewage. And if they are talking about the potential to do that in the future as, Hawai'i Islands get drier, especially on the leeward sides. They're concerned about seawater coming into the water table. We don't have a lot of infrastructure. We don't have a lot of fresh water, so we might need to be creative. And I know the Department of Health, that it is on their radar. I don't know if it's going to happen anytime soon, but it's something that they are considering.
Kiamukenge outfall or outflow land application, what elevation is that?
It's between the highway and the harbor, so it's pretty low.
500 feet?
No, 100 feet.
Pardon?
100 feet, 50 feet.
Oh,
It's below the highway.
okay.
down the sewer, they go down the sewer pipe, from medications to, there's the nutrients, there's cleaning fluids,
Caffeine.
caffeine, and
Pesticides.
all of that stuff ends up in that sewage treatment plant and in those sewage outfalls that come out. So it's an entire cocktail of things that can be harmful to the environment in one way or the other.
And the thing is, we don't know all that's in sewage, and we don't know all that it does. Nutrients is one thing that we've studied really well. We have a pretty good idea of what some of the pathogens can do, but there's so many different chemicals, like the antidepressants, the birth control, all that stuff that we excrete or flush down the toilet, that's going in the environment. Studies have shown that the antidepressants that either the extra medications we have, or the ones that our bodies don't absorb, those affect fish behaviors. So we're just starting to get a handle on what we're putting down and what it's all doing. And there's so many different chemicals in that mixture, we just don't know all its impacts yet.
Tracy, can you give me the other example? Is it the black band disease in coral?
Yeah, so one of the diseases that they have linked, coral disease that they have linked to sewage is the black band disease. So it's actually a bacteria that is found in sewage that is causing a coral disease. It's the first one that has been documented, but there are thousands of different types of bacteria in sewage, and so I'm sure in the future we'll find other examples. We haven't detected black band yet in Hawaii, so far so good.
I have a question for Dr. Looking at that picture of Paradise Park with the amount of cesspools on there, that place is still building up. It's not, I don't even think it's halfway built out yet. And if you got the full built out, would that be more of a problem than like Hilo, there's not quite so much density, or Kapoho, or Puako? That's a lot of houses up there. Full build out, would that be worse because it's more, or is it worse just because Kapoho and Puako are right next to the water? Or Paradise Park has a strip next to the water. But full build out is going to be a massive amount. There's a lot of freshwater discharge out there on that shore, like everywhere.
Well, I think the big concern would be, because I think that is the fastest growing area on the island, I'd be concerned about the drinking water there, even more so than necessarily the shoreline, because people are going to be drinking that.
Yeah, my family has a well down there right now. So
So you want to make sure that that ultraviolet system's working. But yeah, I mean, that would be my biggest concern that, gentlemen talked about earlier is people getting sick.
Most of the marine environment down there, I don't know if that would be how that much. I don't know if anybody ever looked down there.
I know it gets deeper over there, so it's, there's kind of a sharp break and a lot of ocean mixing, but my first concern would be for the population, because they're, the wells and the cesspools are just too close proximity, and we're not regulating that as a county, or putting infrastructure in that could relieve that problem.
We had that well tested down there, it came up okay, but there's still a UV filter set it.
Yeah, I mean, as long as you're testing it along the way.
Well, thank you.
Yeah.
Hi Tracy, so you mentioned earlier about Hawaii being the #1 state for MRSA infections and other gastrointestinal causes. Is there any involvement with the CDC along with the Department of Health in increasing oversight into this?
Well, I don't think we've made the connection that the MRSA is from sewage pollution. In Oahu, where they've done more studies, the biggest source they think is human shedding. So a lot of people in the public naturally have staph growing on them. And so when they go swimming, it rinses off of their bodies. And so in very high density use areas, like Waikiki Beach and stuff, they have a lot more, they have documented infections, and it tended to be higher abundance on days where there was more swimmers. Here, it's interesting because we've had students making measurements. We do see staph in the water, but we don't have that number of people in the water. So what we suspect is it's coming from the watershed. We don't know if it's sewage or some other source. And so our students are trying to figure that out. Where is it coming from here in Hawaii Island, where we don't have really crowded beaches? We suspect it's an environmental source, but we don't know. Department of Health, I think, is involved maybe at the level of maybe infections in the hospital. necessarily those acquired in the community, you know, from recreational water use. We haven't had any like outbreaks for them to get involved. It's just, you know, people have been noticing it, people talk about it all the time, and so now researchers are starting to collect that information. But we still have a long way to go.